Hello again, ACST1052 students. It's Ben here doing another Excel demonstration. So today we're going to be looking at the SUMPRODUCT function and its applications for Excel and how we might use it in this course. So we're going to start off with an example that you'd be familiar with from your statistics course, calculating expected values and variances for random variables. So what we're going to look at is the rolling of a die, so a six-sided die, and we're going to be finding the mean and variance of the outcome of that die. So first off, how you might do this without using the SUMPRODUCT function. Well, we know that the expected value of a random variable is the sum of all of the outcomes multiplied by the probability of that outcome occurring. So I've already put in all the probabilities as being 1/6 for all of the 6 outcomes. So the outcome tells the probability is just the product of the two, and we can copy that down for all of the options. And then our expected value is going to be the sum of all of those products. So we can again use the Excel sum function and highlight all of these. So we can see our expected value of the outcome of rolling one die is 3.5. Now we can do it this way, but we can also use a shortcut using the SUMPRODUCT function in Excel. So if we type SUMPRODUCT and open bracket, we need to put in different arrays. And I'll show you how this works, I guess, with the example. So we take our first array, being all of our outcomes or our X values. Then we put in a comma, and we put in our next array, which is all the probabilities. So what the SUMPRODUCT function is doing is when you give it two arrays, it'll take the first entry of the first array and multiply it by the first entry of the second, and then add the second entry times the second entry and add it to the third and the third. So all it's doing in one step is what we did here, multiplying all of these across and then summing them down. The SUMPRODUCT function does that in one go. And so you'll see that it gives us the same answer, but without this additional column. So then moving on to calculating the variance of a random variable. So you should be familiar from your statistics course that we can calculate the variance by finding the e of x squared minus the square of e of x. So what we're going to do is go and find the e of x squared, or the second moment. So one way we could do this without using the SUMPRODUCT function is add a column over here, which is x squared, and calculate that. So it'd be equals, we'll take the value of x and we'll square it. And again, we can drag this down for all of the values. And then the e of x squared, exactly like e of x, is going to be the x squared multiplied by the probability. And that multiplied by the probability. So why don't we go ahead and use the SUMPRODUCT straight away, since we are familiar with it. And we can take these x squared values and find the SUMPRODUCT with the probability. So again, that's taking the 1 times the 1 on 6 plus 4 times 1 on 6 plus 9 times 1 on 6 and multiplying it all out. So that's one way we could complete this. However, again, we don't need this extra column. We can actually include more than 2 sets of arrays for our SUMPRODUCT function. So if we do it again, we take SUMPRODUCT. If we want x squared, that's really the SUMPRODUCT of x and x. So we can take this section twice. So you can see I've done the x values, comma, the x values again, which will give us our x squared, and then our probability. So what this is doing step by step is going 1 times the probability plus 2 times the probability. And hopefully you can see that this is going to be the sum of x squared times the probability that x takes that value, which is going to be the E of x squared. And you can see it gives the same result. So these two extra columns are not needed here. So then finally, we've done all the, I guess, hard work. We can go ahead and find the variance of this random variable, which is going to be the E of x squared minus the mean value squared. And so we get roughly 2.9167. That's just me adjusting the number of decimal places using the buttons up here to give a more rounded result. Of course, if you wanted to find the standard deviation of this random variable, we can just take the square root of the variance. And so in Excel, the square root is just SQRT. And we can just input the number. And now we've got the standard deviation of the outcome of rolling a single die. So we can extend that quite easily to 2 dice. If we have all the outcomes of rolling 2 6-sided dice, we can get anything from 2 to 12, and we can find the associated probabilities. And it's good to check that your probabilities sum to 1, just to make sure you haven't made any mistakes. But I guess as a quick recap, or maybe you can pause this video and try and find the mean and variance by yourself. But again, using it really quickly with SUMPRODUCT, we're going to take the x's and take the SUMPRODUCT with the probability that it takes that value. And that's going to give us our mean value of 7. Then remembering from before, if we want E of x squared, we can take these x values twice, because that will multiply them and then multiply by the probability to get E of x squared. And then finally, using our formula from before, the variance is going to be E of x squared minus the value of E of x squared. So, and then again, you might reduce the number of decimal places. So you can see our variance is roughly 5.833. And again, we can easily find the standard deviation by taking the square root. So that's all for finding the expected value and variance of rolling a die with the sum product. So following along from the lecture examples regarding using life tables, we can also complete this for finding the expected future lifetime for, in this case, we're going to be looking at a mouse from the lecture example. So you should be familiar with a life table following the lecture. So we have X being the ages that the mouse could live for, then 100. The LX you can think of as how many in a group are alive at that age, and then DXs would be how many have died at that age. So obviously the next LX value, so LX plus 1, is going to be LX minus DX. So we can fill out this table. So if we want to find the expected lifetimes, I've copied this formula from our lecture slides. So go and have a look at the lecture for an explanation on the formula, but we're going to be looking at how to apply it in Excel using the SUMPRODUCT function. So in calculating the expected value, we need these probabilities. So I've already assigned the time of death because we assume that they die mid-year on average. So it's that t plus a half factor. So they could die between age 0 and 1, between 1 and 2, all the way up to between 5 and 6. And I've also added 6.5, but you'll see that that probability is going to be 0. But so this probability is this dx plus t on lx factor. So building that out. So the probability of dying between ages 0 and 1 is the number that died in that year divided by the number of alive at the start. So because it was from birth, you're going to take the full 100. I'm going to use absolute referencing there because for all of these probabilities, we're going to be taking that starting probability. because in this formula, we've always got LX. So in this case, L0, because it's from birth. So again, we can copy that formula down, and it's good to check that it's worked. So if I check this one, we would expect that dying between years 5 and 6, you can see that there was 10 deaths out of the 100 that we started with. So we can see that's going to be 10%. I might change these to percentages. Now, using this formula, we can see it's the sum of the product of this time of death and the probability of dying at that time. So what we can add in is using our SUMPRODUCT function as before, and we can take these two arrays, which is going to take the 0.5 times 5%, 1.5 times 7%, and sum all these all the way through. So we can see that the expected lifetime for a mouse with this life table is 3.53 years. So then the next question in the lecture example looks at the expected future lifetime for a mouse aged exactly 2. So if they're already 2, we're only really concerned with this section of the life table. So I might highlight that to remind us that we've already made it to age 2. So this is our point of reference. So we're really going to be looking at the E of T2, and we're going to be using our L2 factor down the bottom. So the time of death is 0.5 years from now. So the probability is going to be that they die in that first year divided by that they were alive at the start of the year. And again, we need to use absolute referencing because for all of these, we're going to reference that first 82. So we can copy that down. And what you should notice is that for 4.5 years, probably 0. And as a good sense check, we can see how long they all live for. So surviving for 1 year, then 2 years, then 3 years, and then by year 4, all the mice have died. So none can die after the 4th year or onwards. And it's good to check that all these probabilities sum to 1, so that we've got all of the correct factors. And we can see it sums to 1 there. So then finding the expected future lifetime can simply be done again by using the SUMPRODUCT function, taking these times of death and the probabilities associated with it. And we can see that for a mouse age 2, they can be expected to live a future 1.86 years. So that's a quick demonstration on some applications of SUMPRODUCT for both finding the expected value of a random variable and the variance of a random variable, as well as in some life table exercises, including finding the expected lifetime for a mouse in this case, but you can use it in many other applications. So as always, I hope this has been useful, and if you have any questions, feel free to leave a message on iLearn and I can explain anything further. Thank you.